So today my objective really is just to introduce logarithms to you guys. And then the second part of the class we're going to do graphing. We're just going to do one graph today. But basically the main thing you really need to know starting off, first of all, is you need to highlight this in your notes. Y equals log base b x. Or you can also say b to the y equals x. Okay? These two equations will give you the same numbers. Okay? Basically, and just for your own information, you might want to put this somewhere, a log is an inverse of an exponent. So earlier in the week, we did exponential equations. And you remember exponential equations, if you were to graph them, look something either like this for a growth or like this if it's a decay, right? A log looks a lot like that. And I'll show you that before the end of the class, okay? So, here's an example where we have 10 to the 4th power equals 10,000. If I wanted to write this in the log function form of this, I could write log base 10 because this is your base. Okay? And my exponent will be what it equals. So it'll be log base 10 of 10,000 equals 4. Now one thing you need to know is that in the English metric system, what is our base? It's always what? 10. Okay? So in our culture, we're used to a base 10. So quite frequently, they won't even bother putting a base on something like this. It'll be just log 1,000. You can assume that it's base 10. Okay? So log of 1,000 equals 3. It's the same thing as saying 10 to the 3rd equals 1,000. How would I write 2 to the 7th equals 128 in log form?
Log 2,
Yep.
7.
This will be 7.
128.
Yep. Okay. So log base 2, because this is our base, of 128 is 7. All right. Now on this one, we're supposed to go from log to exponential. How did I write this one? 6 squared equals 36. All right. Now, a special case of log is called a natural log. Okay? So that's what you see the L in. This is when you have a base of E. Okay? In certain things in science, you'll have a base E for different things. And E equals about 2.718. Okay? So if I say natural log of A equals B and I were to put it back in exponential form, it's the same as saying as E to the B equals A. One of the things I want to show you on this is that on your phones, if you turn them to their side, where they're the long way, for the calculator, you're going to notice that there are all kinds of buttons here on the left that you can use. Okay? So notice that there's a log button, there's a natural log button, there's an E button, and also at the top there's a Y to the X button. Okay? Now, log in this case, once again, is in base what? 10. Okay? So just remember that you're only going to be able to take the log of base 10 in this particular format. Okay? If you had a CAS or a TI of some kind of another calculator, you would be able to change the base. But you cannot on this. Okay, so for instance, if I wanted to take 2 to the 3rd, I'm going to use exponents. I'll put 2 first, then y to the x, then 3. And if I hit enter, you'll notice it's 8. Okay? If I wanted to find the log of 10, I'd put 10 and then hit log. Notice it's 1. So you have to put the number in first and then hit the log button. Okay, so the reason I'm telling you this is because we don't have any scientific calculators available right now. Okay, and this way you guys can use your phones. You can use your CAS for this time, yeah. Okay. All right. So, let's go back to our lesson. So now let's move on down to the bottom part of the sheet. And I want you guys to tell me, what is log of 100? It's 2, because it's the same as saying 10 to the x power is 100. And so it would be x is 2. I want you to take a few minutes to finish this page, and then we'll come back and check it together. Now this one, before I let you do that, is a challenge question. I want to see if any of you guys can come up with the answer to that. But the rest of it, you guys, if you convert it first to exponential form, you should be able to solve these. Okay? All right, so now you've taken some time to do this, and I'm just going to give you what answers I got, and hopefully you got something close to this. You know this is going to be 10 to the x equals 100,000. So x must be what? 5. Okay? And this one's interesting because this is log base 10, right? Notice that the base is the same as what the log is. So what do you think happens to this? It cancels out, so it basically becomes a 1. Okay? Think about it this way. 10 to what power equals itself? 1. Okay? Now this kind of comes into handy when you come down here. You kind of think about that. Okay? We'll get to that in a minute. All right, so this is 2 to what power equals 32. Now a few of you, I talked to you individually. One of the things you can do if you don't have a calculator handy is you know that if you're doing it by base 2, divide it by 2 until you can't divide it anymore. And then count how many 2's you have. So how many 2's do I have there?
4.
Nope, one more than 4. 5. Yep, so x is 5. So you don't have to guess and check. You can actually keep dividing until you can't anymore. Okay? So 27, if I divide it by 3, because that's the base I want to find, do it like that. So what should be my x? 3. 625 divided by 5 is 125. Divided by 5 again is 25. And then you have 25 and 25. So how many, 5 and 5, I mean.
4.
So 4. So x should be 4 in this case. Okay? So what is this one going to be?
3.
X is 3. This one's pretty easy. X is 2 on this one. X should be 4. This one's x should be 2. 3. Now, here comes the trick question. Remember, if I'm taking log, which is in base 10 of 10, remember that natural log is in base e of e. So what do you think happens to these? They kind of cancel out. So this x should be 4. That's what's left. Okay? We're going to talk about that a little bit more later. When you have an exponent of something that's having the natural log or the log, that exponent actually gets rewritten to the front of the equation. We'll do that more tomorrow. Okay? But that was kind of a trick question. So turn the page. We're going to go to the back side. You guys should be able to answer these questions just the same as what we did before. You need to write them first as a logarithm and then solve for x the same way that you did before. These ones right here, These three you can use your calculator. You actually have to use your calculator for. Okay? So if I were to find this one, I could rewrite it as log 79.1 equals x. Now if you're using your phone calculator, you're going to have to write down the number 79.1 first and then push the log button. Okay? What button would I use for the e to the x power? Natural log. Yeah, so it'll be ln 19.2. Okay? And then I just have a couple more that I want to demonstrate with you. Yeah, you have a question?
What is the definition of a log, and when would you ever use
It is actually the inverse of an exponent. And so when you're trying to solve for exponents, when you have like an x or a
it?
y,
Like working backwards.
yeah, it makes it easier. Okay? So this one is going to be hard, so don't do that one today. We're going to do that one tomorrow. This one too. But I wanted to point out this one right here. This is like saying 5 to the x power equals 0.2. Okay? How would I write 0.2 in fraction form? 1/5. All right. So 5 to what power equals 1/5? It's going to be a -1. Remember that anything to a negative power puts it down on the denominator part of a fraction. So if I said 5 to the -2, what is that going to be? 1 over 5 to the second, which equals 1 over 25, right? Okay? So you're going to have to put these ones that are in decimal or in fraction, you got to have them in fraction form first of all, and then you got to figure out how many times the base goes into that. Okay? So there's one right here. There's one on the, there's all three of these on the bottom are like that. You're going to have to do that. Okay? If I wanted to graph log base 2 of x equals y, basically, I'm going to, instead of putting an x value into it to solve for y, I'm going to start with the y value. Okay? We're doing it backwards because remember that a log is really the inverse of an exponential function.
So it's x.
So if I put in, if I put this in exponential form, I get this right here. If I pick these values for y and put them in for x, I put them in to find x, I'll have 2 to the -2, so x would be 1/4, and that was my first point.
Wait, how did you get the 2 in the first place?
Because I just made them up. I just pulled some points out. You know, like how we used to do with x's. Now
So you just started.
we're starting with y, yeah. Okay, and then 2 to the -1, huh?
Where did you grab
I put it right here. This is 1/4, so it would have been right there.
that? I was talking about the 2 for log base 2.
Yeah. Oh, that was just given.
Okay.
Okay.
That's what I meant.
This one would be negative. 1/2 is -1, so that would be right here. And so on. If I keep graphing all these, I get this thing that looks like that. We've seen that before. And where we have seen that is this is just y equals x line. And you can always use that to find your inverses. So what does that look like? This is y equals 2 to the x power. Okay? So it's the inverse of that. So that's the mirror image, that line. Okay, so that's it for today. And tomorrow we're going to learn how to do operations with logs.